Okay, so that's the dollar we'll frequently use when we talk about the data analysis. And there's some metrics. Metrics, you can do addition, you can do subtraction, you can also do multiplication. Basically, the metric is you can do division once you have the inverse. Of course, when we do the addition, the two matrices should be, have the same size. This is the 4 by 3. This is another 4 by 3. Let's say we wanted to find the addition. You can do 1 by 1. But actually, you can, because the addition is, I don't know what happened with the stupid computer. Another selected. Okay, so because the addition is again it's 4 by 3, so we select the area. It's the matrix. It's not just one cell. It take it take an area of the cell. You select this cell, and then you select the first matrix. Matrix A. Matrix A is here. You just enter plus, and then you select the matrix B. Okay, and here you remember last week, three keyboard. Control Shift Enter, and then we immediately have the addition. So you can check. So this is 2 equal to 1 plus 1. So this is 4 is equal 1 plus 3. And subtraction is the same. It's simple. So now I go to multiplication. For the multiplication, we need to use a function. So the multiplication, the second division of the matrix A must be equal to the first division of matrix B. Otherwise, that is impossible. But the matrix is like the first row multiplied by the first column of the second one. So the number of elements must be same. So what's the matrix? What are the divisions of this of the matrix? Multiplication A by B. A by B is what kind of matrix is A by B? So A is 4 by 3, which means 4 row, 3 column. B is 3 by 5, 3 row, 5 column. So how large is the matrix A multiplied by B? 4, 5. Okay. 4, 5. So we need to select that area. So I remove this. So I select 4. So this is 4. And by 4 column, 5 row, 5 column. Okay, you select the 8, and then you click the place. We input the function. So the multiplication is the function called the MULT. So the first M here means the matrix. MULT, you can guess what does it mean? Multiplication. Yeah. And so that matrix is multiplication. Then you select first the matrix, and then you select the second matrix. Again, the three keyboard Control Shift Enter. So immediately you have the multiplication. Transition. What is the transition? Transition is just the row become a column, and the column will become a row. So the 3 by 4 will become a 4 by 3. So the function you use is transpose. So their function called the transpose. So it's a more challenging is the inverse. So inverse for me probably I can find the inverse of 3 by 3, but after that it's very hard. So but in Excel you just use the function. Not selected. Okay. Of course, the inverse means for square matrix. Let's say this is the 5 by 5. Of course, the inverse is also 5 by 5. So you select the area. We are going to save the inverse. Okay, and then you go to here. So here it's M inverse. So M again means the matrix. Inverse is the inverse. Okay. You select the matrix. Okay, and then the three keyboard, so immediately you have the inverse. So you can, as X said, you can find the multiplication of matrix A and the inverse. Try. Control Shift Enter. Yeah, try to find the multiplication of the matrix A and its inverse. Of course, it's again it's a 5 by 5. So I select the area and I use the MULT. It's matrix A with the inverse. Control Shift Enter. What do you have? So there's a name for this matrix. What's the name of this matrix? No, I mean this one. Only the diagonal, basically diagonal is 1. Everything else is zero. There's some, it's not a zero, but there's some truncation errors. The diagonal is 1, everything else is 0. Yeah, it is a diagonal matrix, but you know, everything in the diagonal is identical. It's an identical matrix. I always use I, identical matrix. Okay, so next one is LSE. You know, in Excel, you can also do a linear regression. Actually, the linear regression you can use. If you don't remember, so this is linear regression. Let's say we have a y here, and these are the x. We want to find the you know, coefficient b. If we have a equation y, if we have such a model, we have the y given here, x given here. We want to find the coefficient b. So if we, I think, yeah, you can use this formula. It's just some, you know, some metrics operation, inverse, transpose, and you know, this is the vector. Vector is a special case of matrix. It just, so basically you can use what we showed before to find this value. I hope if you can do that, you know, it means you are very fluent to use Excel. But there is a function, a special function to find the coefficient, which called the linear, is a linear estimation. So it's called LLEST. LL means linear, EST means estimation. So I just show you how to use this one. So by using this function, it will output your several things. It will give us, you know, the coefficient and the standard deviation of the estimation, and also R square we call the determination of the linear model, and also the F test. You know, it gives us quite a number of things. But please remember, you know, the coefficient is in the opposite order. So basically, the constant is the last one, and the first one, second one. I don't know whether Bill Gates, you know, make this function like this. So so this one, and then let's see this. Actually, I changed the title. It's like a B0. It's like a B1. It's a B2. So this from genetic data actually have some genetic meaning. So I select the cells. You have to select, you know, for the whole. Of course, if you have you have a many B, it should be coded like this. You have B3, you should select the 4. You know, because of the coefficient, you know, including the constant, we have 4. We have a 4. So the row number is fixed. So you always select the 5 rows. And then I go to here, I input the I linear estimate. And here, this function actually tell you first you need to tell what is the y. So this is our y. Yeah, this is our x. And the constant, there are some option because in this data actually b0 is a constant. So it should not be considered again. So the b should be equal to 0. So here just we select the 0. And here we select the true. So we wanted to return some statistics. So it's always like a false you can input as 0, true you can use as 1, and Control Shift Enter, so we can have have all the estimate, the coefficient, standard deviation, and the R square, So basically, this is also available from data analysis. We should the last time data analysis.
Are linear estimation and linear regression both are same?
Linear regression and
linear regression equation and linear estimation.
No, linear estimation. Well, it's linear regression. It's more focused on the model, maybe. So linear estimation is estimation of the linear regression model. So you can understand that. That's the linear regression and the linear estimation, right? You ask the linear regression and the linear estimation. So I think the linear regression is more focused on the model itself. Estimation is about you find the parameters included there. It's not exactly the same. Statistics, I think we talk about this last time. Data analysis will come back later. So let's see what else. Okay, probabilities. That's what the major topic today. We wanted to find some probabilities. Let's say we have a normal distribution, and it's a standard normal distribution as an example. So now I find the probability for the form value minus 1 to 1. So let's see if we use this function. So the normal, basically there's a special name. Let's say if you input, you see if you just input the norm, you see many, well not many, just a few things, just to give you explanation. So this represents any normal distribution. So the norm S, the standard, only for standard normal distribution, which means mean equal to 0, variance equal to 1. So for if you use this function, because the mean and the variance are known, so you don't need to tell the computer what is the mean, what is the variance. But for the first two, you have to tell what's the mean, what's the variance. Okay. So what's the difference between this one and this one? So this one actually, we form the distribution, we find the probability. If we know this distribution, we want to find any probability. So the probability, basically, that's the left tail of probability. So it's the area here. So that's a given A. we want to find this area. So you use the first one, DIST. So there's another one, given the area. If I know this area, I want to find the value of A. So that's the inverse of this this problem. You know. So given A, we want to know the probability. So you use the first one. Given the probability, we find this value. So we use the IMV, the inverse. That's basically use the same thing, but you know, let's sometimes we will have this function. If we given x, we want to find y. But sometimes we know y, we want to find x. So that's what we call the inverse, no? Yeah, basically that's the same machine. But the function here is not that simple. You remember what the standard the function here for the standard normal distribution? I hope you everybody remember that. Okay, so because this function, yeah, well, no, actually here the function is the it's not that here we talk about the p. P actually is the integral of this one. So it's very hard, you know, to write a simple formula for the normal distribution. Of course, that's the mathematicians' work. They, you know, they find that, you know, how to find these values. Okay, so now you see for many other distributions, you see the similar thing. You see there are two functions. Four is called the distribution, another is the inverse. So now you know the difference of the two things. So first we know x, we want to find the probability. On the other side, when we know the probability, we want to find the x. That's called the critical value when we do the inference capacity test. Okay, so so basically this function tell us, you know, the probability. The probability when the A is lower than -1. And we have another probability. So here we ask the probability between -1 and 1, right? So this here, let's say it's 1. This is the -1. So if we know the area, you know, on the left side of this line, and we know the area, you know, on the left of this line, so the difference will give us, you know, now we want to find this area. That's this interval. So the first function actually gives us the probability on the left of this, you know, everything on the left, and everything on the left take away, you know. The take away this tail will give us this interval. So then I don't know what happened with this computer. Okay, I just find one. Okay, so first I find the probability. We just use the you know the not the standard one. I just use this one, and I tell x. X is -1. I just click this one, and then I need to tell the computer the mean of the normal distribution. and the variance, because this is a standard. And here we see there are two options, is true or false. So if we give true, actually if we give true, we will only have the hat of this one. Okay. So let's see if this one, so it's only actually tell us this point. If we input false, that's the hat. If we input the true, and then that's the area. So here we wanted to the probability. So we don't really want to know how high is this, at this point. We wanted to know the probability. So we give another, we give 1. So here it's like the accumulated. So I do enter. And next I find the probability at point 1. It's normal distribution. And the x equal to 1. Mean is 0. Variance is 1. And again is true. And then, of course, as I said, the whole area, you take away the left tail, and then become, something in the middle. This value minus this value give us the probability. So you can see everything else here. So this value actually is used in statistics. There's some quality control. They call it the 3 sigma principle. But the 3 actually, so this is the probability, if for any distribution, we do some centralization, we do some standardization. So this can be treated as the 3 terms of standard deviation, or 3 sigma. Standard deviation, actually the variance is the sigma square. The sigma is the standard deviation. So this is called the 3 sigma principle, because if we have a normal distribution, everything almost the 99.7 should be located between the 3 sigma. When we see, some values, is lower than 3 sigma or higher than 3 sigma, sometimes we see it's an outlier. In some quality control, that's how we, make a decision which value is the outlier. Okay, so the next is about, if I know the probability, I want to find to find the how large is x. So if I know, let's see. Okay, I just show you one example, and we can stop here for today. Okay, remember normal distribution is symmetric. Okay, it's a symmetric. Actually, if we have a minus one here and a one here, the height is the same. And if we talk about the area here, if we use just use alpha here, and the area here is the same because of the symmetry. So this we always call the left tail. Is called the right tail. Okay. Now let's say we wanted to find if we have this probability, if the x we want to find the x and give us the probability 0.6 in this area. So now we want this area, we know it's the value 0.68 what 6827. How large should be the x here? So well, I just put a A. Of course, this is I think A is positive. There should be there should be this is A is always positive. Okay, so this is the 0. So how this question is if I know this area, I want to find the value of A. But this area, the function, okay, here. This function actually gives us, if we know the left tail probability, it tell us, the x value. So this area is not, the left tail because we take the left tail. But how can we find what's the area here? Let's say this is this is summation A or no B or no. Just P. Maybe alpha. Some alpha there. If I know this area is 0.68, so what's the area of this area? What's this area? How we find it? No, don't consider P. Let's consider the area, the probability. We know everything in the middle is this value. So how large is this area? How large is this area? I think this is the preliminary school. This is, the whole area. How large is the whole area?
This one like this two.
How large? I mean, how large is the whole area under this curve? That's the one. Because that's the probability for for everything. So which means R plus this one plus R equal to 1. And then I think everybody can find out the value of R.
You are confused about 1.
Confused about 1. So that's 1 is the whole area under this curve.
Standard.
Why 1?
So this is the standard. If we don't have a standard, we just do some centralization and standardization. So here we talk about the standard normal distribution. Now let's find then we can, if we find the R and then this function, if we know any left tail area, we can find the value of A. So that's this function. So that's why here we need to find out basically it's the well, you can find this area or if you want to find the a value, if we have the r and then alpha plus this area will be the probability for on the left side of this line. So I think the here yeah it's not really r actually here this column I give the alpha plus this probability. So and then if we use the inverse, we will find the value of a. I think you can only let's say if we only find the alpha, what's the alpha? Alpha the alpha. I don't like this computer. Okay, maybe let's find the alpha and find the a, but definitely a will be a negative here. So the alpha at here should be 1 minus this probability divided by 2. Okay, you agree? 1 minus the probability divided by 2. So give us the area on the left of actually the left tail probability. And then I find the value x. I use the normal. Still, I use the normal distribution. So no, I use the IMV. You cannot use the inverse. You see here, it asks you input the probability and the mean of distribution 0, variance. Remember here the Excel they ask the standard deviation. So if you have the variance, you need to make a square root. So the E it doesn't matter, and enter. So it's exactly minus 1. Okay. So if of course if you use this this area, and then you will have a 1. Okay. Now I think you should have any problem to find the other probabilities. So we stop here today.